Hey guys, I'm Nick and welcome to the new tutorial. In this one we will take a look at actually meshing the Pyro simulations and also distorting the UVs, which was super tricky, and multiple times I thought that, oh alright, this approach works, and I got it, and then I rendered it out and I see how all the UVs just float away. Also, I need to mention that this example with Pyro is one of the kind of extreme expansions, so definitely we will see some extreme stretching of that texture. But anyhow, I think this Pyro meshing and UV extension technique might come handy in your project. As you can see here, the scene setup is pretty simple. I actually might add just in the camera that's top down. And talking about the top down cameras, so here is all the stuff that we will go through. But if we just visualize our watch that I downloaded from, I think, Sketchfab and modified quite heavily. The thing with the cameras is that if we just drag and drop another one and target it here, if you are working with a top-down view and you want the kind of not like isometric view, but I mean this focal length. So if we go with something like 30, you can see how we are zooming in and it becomes a bit distorted, you know. So yeah, so the focal length actually it distorts the picture, and the smaller it is, the more distorted it will get once we zoom out. And now if we zoom in actually, and now if we set it back to 125 as it was here, you can see that it's much less distorted and it's more like a true top-down view. So yeah, we will talk about the materials a bit later, and also our slide dome with this Brown Studio HDRI, which has zero saturation, and I don't know if we enable that in viewports, will we be able to see it? Yep, we will. But yeah, it's this Studio HDRI that I use nearly in every my project. I used to use just like 3-point light system, but I found this HDRI and I actually really love how it actually lights up objects. So now we can uncheck it here, and maybe we want to enable backgrounds, but remove the background itself, remove the environment, so we don't render out the HDRI actually. And yeah, materials, we will talk about that a bit later. So let's go in our geometry node and see what we got here. So we have 1, 2, 3, 4, 5, and of course six logical blocks that we will talk about. Yeah, we import our mesh, we do the Pyro sim, then and here's the deal, we eject the particles from that Pyro source sim, because what I wanted to do is just place the VDB here when we have our out smoke. We could probably VDB convert here, VDB convert VDB, and then we could just convert to VDB, VDB class convert fog to VDB, and it should work. Now we convert VDB again to polygons, and yeah, it should be good. As you can see, it's a decent VDB. If you will add, I don't know, maybe some VDB reshape or VDB smooth, it will look good. And this works perfect for some either non-textured or static simulation, because you actually cannot apply UV textures at this point, because you need UV textures to stick onto something, and whether it be points or vertices, actually vertices, not vertices. But here we don't have none of that data, and that's why we actually need to go through that another meshing process that I will talk about later. But yeah, just in case you don't want to texture it with some sort of texture like I did, and you want to use just plain color, you can always go with this easy route here. But yeah, let's go one by one and see what we got here. So of course we dropped our watch, which is ginormous. we converted the alembics to the polygons, convert to polygons, and then we drop this mesh size and make it match the box, which is 2 by 2 by 2. So it's much smaller and it's somewhat measurable. I mean, that watch that I imported, it was too big. And now we want to do a few things. So here's our first attribute transfer. And what we want to do here is to generate points for our Pyro source, but also we want to generate the normals on our points that then we will be using to kind of spread the fire, you know, or another fire actually, to kind of drive the smoke. So what we are doing after our mesh size, we are dropping points from volume. This point separation, in my case, it's set to 0.01. All the other properties are default, I think. Let me just, yeah, you can try with 0.1 or 0.05. Do a few tests how you like your Pyro source to actually like swirl and billow, and then do this 0.01, which is a bit more high res version. And yeah, then we also connect our mesh size to the normals, and add normals to points should be checked because it's set to vertices by default, but we want to compute them on points. And then we get our attribute transfer. Here we have max sample count set to 10, and we transferred our normals to our points that we generated. And if we visualize the normals, display normals, here you can see our normals on points. So now we need to create the temperature attribute. And in this case, I create the temperature, which defaults to 0. And we can possibly just visualize it using the temperature. Yeah, so here the temperature is 0 because we just created that attribute. We set it to be float, and both default and value are 0. Now I want to add noise to that temperature to make it actually somewhere to be 1, somewhere to be 0. And here's how you can do that with attribute noise. Attribute names set to be float temperature, range values, in this case 0 centered and amplitude set to 1, noise pattern Manhattan cellular, it's difficult to me, but basically noise type Manhattan, element size 0.1. And of course I suggest you checking out different noise types and different fractal settings here. So now when we have our kind of like heated regions, or the points that have temperature, we want to add this Pyro source spread node, which gathers the information from this attribute noise, and now it will add all the necessary attributes that Pyro source needs. So in the temperature change, the only things that I changed were cooling rate to be 0 and rate to be 0, because basically we don't need nothing from that Pyro source spread. The only thing that we need are the attributes that it creates: burn, diff rate, fuel, fuel gain, all that stuff. So then this attribute wrangle actually, let me just bypass it for now, and we go to the Pyro source and we will play the Pyro solver, and then I will talk about this attribute wrangle here. So in the Pyro source, particle separation is bind to the points from volume to this point separation. So again, I can copy parameter and I can go here in Pyro source spread, in Pyro source, and here I can paste relative references. So now we bind this parameter to that parameter in the particle points from volume, and we can click initialize source smoke, and we will have these two attributes generated automatically. Then we go volume rasterize attributes. We don't rest actually here, we don't need that, but yeah, voxel size here is also bind to that particle separation. Coverage scale of the density I set it to be 2, and check the normalized by clamped coverage. Just gives you a bit better smoke, especially for the point advection later. And attributes here are density, temperature, burn, and V velocity. And then we go into our Pyro solver. And here are a few interesting things. So this voxel size again is bound to that points from volume, vertical separation. As you can see, substep set to 1 everywhere. Bounce, my main emission was going like down. It was kind of buoyanted by the gravity. For now, it's not necessary, I think, because we actually have our, in this case, our smoke driven to the right side, which is, in this case, it's X. Also, let's enable the camera, just, yeah. But basically, if you leave it at closed below, it will basically treat that axis value that you set here as sort of a collider, so we can select it to be open. For the sourcing, yeah, just 5 frames, so limit source range is checked, and frame range 1 to 5. Collision, nothing in the fields, dissipation set to 0.01, and in the shape, so buoyancy, actually, here's the trick with the buoyancy. So disturbance, turbulence, we will talk about that later. There's a trick there too. So let's get back to this attribute wrangle. So velocity. Velocity drives our particles. That's the initial force, which is vector, which is the direction of the movement of the point. So in this case, I am getting the normals as my base direction as a vector in which I want to go. And talking about the normals here, yeah, we cannot see them because we have volume, but still we have our normals here and we are rasterizing. That's why here in the Pyro solver, it will catch that normal attribute. And speaking about the force, here we have the temperature. And you know that temperature, basically all the red values here are burning, that they have that temperature more than black and gray values. And the K is kind of like coefficient that I just added to kind of control how much that temperature influences the velocity, because the bigger velocity, the faster the point will travel. And if I play this simulation right now, you can see that black parts basically stay the same, but these parts that are burning right now, they are going in the direction of the normals. And maybe if I also uncheck disturbance and turbulence, we will see that even better. Also, we maybe let's keep the points from volume, point separation the same as it is. But basically, right now, what you can see is that the base mesh stays the same as it was. And base mesh, saying base mesh, I basically mean the black parts that don't have that temperature, and all the parts that has that temperature more than 0, they will try to escape because we again have that velocity added. This coefficient here, we can let's set it to 1 and just see what we got here. So with that coefficient 1, we adding more velocity to these parts, and here you basically can see it better. And maybe at some point you want actually this effect rather than mine that was using the buoyancy also. Yeah, no one actually restricts us to the both velocity and buoyancy. And here's the trick with that buoyancy and talking about the buoyancy and turbulence. So what I want to do here is go to the, no, not the Pyro solver. I want to go here and let's enable turbulence. We have our buoyancy turned off. We have bypassed our attribute wrangle with velocity. And in the turbulence, you can go inside and check this use control field. And in my case, I'm using control field temperature. in control range 0 to 1, which is our initial temperature. So main thing here is that if we are using control field, we can specify the field that will control the amount of, in this case, turbulence applied to the points. It's basically similar to this value, this temperature value here, because it's basically the same thing, that we add velocity to the burning parts, the parts that are burning right now. So here in the Pyro solver in turbulence, if we check that, you probably won't be able to see that that clear, but yeah, I think you're able to see it, because you see how these parts start moving and dancing around, and we don't have buoyancy, we don't have anything that would drive these particles. But because we have this control field here in the turbulence, you can see that only the heated or burning parts are turbulent actually. And if we uncheck that, use control field and play that simulation again, you can see that all the parts start swirling and dancing around. Of course, burning parts, because of the pyrodynamics, will be a bit more turbulent, but still. So use control field here. And for the disturbance, same thing. I just used a different value for the temperature and control range here. For the buoyancy, so gravity acceleration set to 1 and buoyancy scale set to 1, so it's not that much of a buoyancy because this should be 9.8 as our default world scale gravity, and gravity direction is set to -1 at x-axis. So if we combine everything here, the velocity from our temperature range, then in the Pyro solver, buoyancy, disturbance, and turbulence, we should get something like this. So here you can see that we have our burning points fly away to the right side, to the -x, pretty fast, and that's exact thing that we want here. So we can simulate. In my case, it's 90 frames, so it's a lot of smoke here. And just in case you want to retime it to be slower, because you can see at frame 30 we have pretty extreme expansion of that mesh. You can do that by dropping a retime node, and let's say we want to slow it down 50%, so speed should be 0.5 and volumes advected 0.01, interpolate velocity field, should be good. So if we go back, yep, we are at the frame 15. Yes, we were at frame 15. And you can use this retime in order to probably skip retiming here and here. But that's another approach that you might want to explore, and I encourage you to explore different approaches that I am just like briefly talking about, actually exploring it yourself. So for this case, we don't need this retime node here, and we will be working with these 3 blocks, logical blocks here, and yep, basically we've done our smoke sim. If you want just static frame, again, VDB from, no, convert, VDB, convert, we can drop it here, convert volume, no, VDB, VDB class, convert fog to SDF, and again, convert it again to the polygons, and boom, you have your meshed smoke. All right, so now the heavy part. So we again create points from volume. So point separation is that same 0.01, and we need to add this class attribute. And this block of code that I found on some Oddworth threads, and following the rabbit hole, I ended up in this tutorial by what I found about UV mapping vicious simulations. And basically this is an awesome tutorial for all the flip simulations. I needed to adapt it to my simulation, but the core kind of logic is the same that this guy has here, which is splitting the simulation to the chunks and then running it through the loop. And that's how you can basically mesh, not the mesh, but add UVs, kind of constantly add UVs to the simulation that is evolving. The link to this video will be in the description of my video on YouTube. So this attribute class, we will need that later in that for each loop. And what we want to do is create the value, which is, in my case, that updates every fifth of the second, and we're using a function called floor to make it integer from the float value. What it does here, if that we have this class attribute, we scroll the timeline and we see that class attribute actually at the frame 6, the frame 7 it's 1, and the frame 14 I assume, or no, and the frame 13 it's 2, and the frame 19 is 3, and it goes on and on and on. And this class is integer type and goes over points, and we need that for this for each loop. But main thing is popnet, because we will be using our velocity from the smoke to drive our particles, and unfortunately you cannot bypass the thing because you basically attach the UVs to the particles. You attach the UVs to these points. And that was the catch for me, who thought that, oh cool, I measured the smoke with this, this VDB mesh thingy, just 2 nodes here, and cool, now I can attach UVs. Nope, it's not like that in Houdini. So yeah, going into the popnet, what we have here is source first input all points, first context geometry, and this pop divided by volumes, which is a well-known technique. The only thing that I actually do here is after the frame 30, I decrease the velocity blend. In the SOP, we have our out smoke, which is basically our smoke, and yeah, added a pop drag just to kind of slow it down a bit after the frame 60. But yeah, I think that's it with the popnet actually. And if we file cache these 90 frames, you can see how it expands. We have our particles that follow our smoke. Yeah, that's it. 90 frames cached out. You probably could just render particles if you want, but that would be your particle direction. And in this tutorial, we're talking about the meshing. So here's the trick with the retime. And yeah, let's talk about the VDBs for a moment. So I wanted to retime this animation. So input frame range 1 to 90, output frame range 1 to 180, speed set to 0.5, use velocity when interpolating position is unchecked, and yeah, in attributes and volumes it's all default. So we are creating VDBs from particles. We need p-scale because popnet does not add that by default. You could also check add scale attribute here and don't use this p-scale here in attribute triangle, but I went with this one because I just forgot it to add here. So p-scale 0.01 and VDB from particles. So voxel size 0.01, point radius scale 2, because we want sort of a, very blobby looking VDB, and we don't want any holes and protrusions in our VDB. So point radius scale 2, point radius scale 2, minimum radius in voxels 0. VDB reshape SDF set to close, and offset also set to 2, and VDB smooth, mean curvature flow, iterations 4. And now convert VDB back to polygons. So a few things here is that we go with the VDB from particles, and yeah, I wanna set the frame to be somewhat like 60, where we have our blobs already. So if we have our VDB from particles point radius scale set to 1, you will probably see more protrusions that I have right now. Yeah, here you can see that. And also if we have our VDB reshape as they have set to 1, we will see even more protrusions. So that's why for this one I would say let's go with point radius scale set to 2, just so we have this blobby something. Of course, it's better to add these convert VDBs here into our file cache and our outsmoke. But yeah, again, I haven't found a solution to actually attach UVs to the straight meshed Pyro. And yeah, basically after convert VDB, we drop another file cache. And here you can see I have a lot of file caches, but that helped me to preview that and actually see that everything is working fine. Here you can see you can see a bit of erosion here, right? But yeah, cannot do much about that. That's our simulation. That's our base mesh that we will be attaching UVs on. And speaking about UVs, so let me recreate this for each loop. So for each connected piece with meta import. So we don't need connectivity. We just want to go in for each end and set this by count, iteration method by count. And yeah, that's basically it. That's all that we need to do here. For each begin should be fetch input, and yeps, that's it. So the thing that is going on here is that we get our class value. Let's go to the frame, I don't know, 10. So the main thing that we have here is that we are working with the chunks of our point cloud, and we are constantly adding UVs to that point cloud. So we want to delete any points that are not with that class that we are iterating right now. So this for each goes with iterations. So 1, 2, 3, something. It can go whatever rounds, whatever iterations you set it to be here. So here you can see this expression, which is very similar to how we gather point information. And this class attribute, right? It's the one that we have created here in the attribute create. So in the file cache, we have our class attribute, which goes 3. Some points have it to be 2 and 1 and 0, and it depends on when that point was emitted actually. So we want to target here, and we want to delete any points that has not class attribute equal to the current iteration. And you have here data attributes, iteration, enumerations, value, and I value. So we want to delete every point that's class attribute is not equal to the current iteration. And current iteration, we can grab it from the detail function, get detail, from our metadata, which is for each begin one metadata, this one, for each begin one metadata 1. We want to grab iteration from it, and 0, yeah. And don't forget these little the tilde signs here. Not the tilde, but it's shift tilde. Actually kind of Googled that and copy pasted because I don't have it on Mac. But still, so, and delete non-selected entity points. So, and now if I reset the for each metadata block, we can see that if I target this delete, and because the iteration starts with the 1 and not 0, but class starts with 0, we don't have anything at the frame 1 to 13 where the class attribute is actually 2. If I visualize the file cache, you can see that we obviously have some distortion going there, but because we have deleted all the chunks, we are in this loop, we are working only with this piece of our simulation. And if we go 25, and you can see as we scrub through, we see that we don't have that much particles that we should have, but that's actually a correct behavior because we are deleting all the particles that were not emitted in that frame range that we set up in our attribute create class. We're deleting all the particles that were not in the 1/5 of the second, and second being 30 frames, so 6 frames is the range for one class value. So after that delete, we drop a time shift, which again, here we grab that same detail attribute add 1 and multiply. In my case, I'm multiplying that by 7, but I will show you why this number should be adjusted per simulation, per project. So yeah, again, then we drop a UV project, your default UV project, but it should be projected on points, not vertices. And you can hit this initialize to best plane, and you will see your UVs. Oh, you actually won't see your UVs because these are points. And then we copy our attributes from this time shifted version to our version that goes from that delete. And we wanna match by attribute, match by our ID attribute. And that was one of the key points why I went with this setup with the popnet, because I don't have any attribute to bind to when just meshing out smoke. So we match the attribute by ID, and attribute name that we want to copy is UV. So here's the deal and here's the trick. Let me get back to the frame, I don't know, maybe 18. And let me drop attribute from map. Attribute from map. Now connect it, and boom, we have our UVs. So at the frame 1, everything is kinda okay. We have a slight bleed here, but yeah, still it's a decent UV. Then at the frame 15, for example, or actually at the frame 30, you start to see that craziness going on in these areas here. Maybe, yeah, let's say frame 20. I just want to be sure that you are able to see these chunks, actually see the UVs. So for these iterations here, so here's the deal. If I set this to be 6, you will see that we have slight change here in these UVs. If I set this to be, I don't know, 15, and then I scroll to the frame, I don't know, maybe 50, where we have really big distortion of the UVs, and then we again should compare that to the 3 iterations. And now let's compare to just 3 iterations. Here you can see how stretched these UVs become here. And also, if we come back to this time shift here, and let's say we want to multiply it not by 7 but by 3, and if we again let it cook, you can see that we lose all of our UVs, because this multiplier should be more than your multiplier in this class generation step. So after you have graduated from Hogwarts and understood this dark magic, you can file cache your UVs out. And yeah, let's go here. I suggest you playing with different values here in this for each, because to me it was extremely hard to understand and even harder to explain how this block of code actually operates. I mean, I can understand the logic behind that, but splitting your geometry into the chunks that being UV mapped in a for each loop it's quite a concept, you know. And again, credits to this approach goes to the What I Found channel on YouTube. But once you cached out, you can plug the attribute from map to our file cache, and now we can see how our UVs get distorted. And they are getting distorted pretty well, I should say. We see that they are actually stretching, and we don't see any flowing texture on the surface of our watch. So pay attention that I'm retiming my file cache after I've done everything in the UV block, and I'm retiming everything before I've done everything in my VDB block. So that's the main difference here. And yeah, again, we can use this attribute from map if we want. We can bypass if we don't need it. It's just for the visualization purposes. And then the main block of code that produces that gets us where we want is attribute transfer. So for the attribute transfer, we want to transfer the UV attribute from points, and max sample count set to 200, distance threshold to 10. Now, after we file cache it, add normals. We will talk about this attribute blur a bit later, but if we add UV quick shade, now we see our UVs that, of course, in this situation are distorted enormously. But we can see how, yeah, we have a bit of float, you know, here in this part, but then we kind of distort it very, very, very drastically. What we want to do here to get a bit more smoother UVs, we want to add this attribute blur, attribute set to UV, blurring iterations goes to extreme 200, step size to be 0.8. I tried with unchecked pin border points, but actually then it goes a bit jittery, you know, and that's why, yeah, pin border points should be checked. But yeah, with this attribute blur, you can see that we don't have these kind of lost chunks that are kind of just lost its shape completely. With the attribute blur, we have a bit more of the distortion. We still see something, some shape of that UV, you know. So yeah, that's it, guys. And probably you could slow this simulation a bit more, but just wanted to show you the concept. And this UV meshing is super tricky. Also, another trick to render it out properly, we want to remove this UV quick shade, or at least keep our display render tag on the attribute blur here. Now we can talk about the materials. And for this one, let me actually switch to the redshift view and fire up my render. So let's get back to the camera 2. Let's get this one here. We want camera 2, and here we have our mesh textured in all of its beauty. So here's the deal about these materials. So we don't need this one. I will make another tutorial about the kind of procedural marble material, but if we plug it here, it was my first version of this kind of white something. But yeah, with this level of distortion, it doesn't look like marble at all. Probably need a static geometry for that. But the trick that I made here was to actually grab a texture from sort of a free pick, and then I changed the color of it in the Photoshop, just remapped the colors. So I'm using two versions of that picture. One is grayscale that I plug into the bump map and then plug into the bump color. Here in the bump map, the height scale is set to 0.03, and effect by object scale is unchecked. Here you can probably see the bump map here. And then the texture sampler with my main texture goes into the RS color correction. And what I did here, I played with these values, but actually went with just a bit lower gamma than it is by default. And yeah, it goes into the diffuse channel. For the roughness, I'm using 0.065. And also I have my coating weight set to 1 and roughness set to 0.2. So yeah, I think that's it, guys. And here you probably can see how that mesh expands and also distorts quite heavily, distorts our UVs. Oh, and I forgot the rendering part. So yeah, I have two ROPs for two cameras. I just haven't rendered out the top-down kind of wide shot camera. But anyhow, I am rendering PNGs with post effects turned on, with min sample set to 16, max samples to 512, threshold 0.001, refraction no overrides this time, global set to 8, brute force trace primary GI engine set to brute force, trace depth set to 8, secondary GI engine set also to brute force, and brute force trace set to 1024. So yeah, I think that's it, guys. I would love to see what you come up with using this technique. Tag me or send me your creations in Instagram or Twitter. It will be interesting to see where and how you use this technique. But I will be back next week with a new tutorial. Bye!